Hi, we are working on 6.2, multiplying and dividing rational expressions. Please read through all the notes. I am going to be working on just the examples. Hopefully they will be helpful to you. And let's begin. Remember, when you're multiplying rational expressions, you multiply the numerators together, you multiply the denominators together. Always remember that if you can factor it, sometimes it is easier to factor it first and then reduce it and then multiply together. All right, when you are multiplying fractions, you can reduce them vertically and you can reduce them diagonally if you choose so. So on this problem here, 2/7 times 5/10. I'm going to actually simplify it by this. 5 goes into 5 once, 5 goes into 10 twice. I also noticed that 2 and 2 also go into each other once. So if you guys can reduce it, try to reduce it down to as far as you possibly can. It just helps multiplying across easier. Now I have 1 times 1, which is 1. I have 7 times 1, which is 7. So that answer would be 1/7. Now here, this is a little different. When you are multiplying powers, I don't like simplifying powers first. I take care of the coefficients first, but the variables I wait till the very end. I just think it's more helpful. So on this problem, what I'm going to do first is I'm going to simplify the 3 and the 9 because these are diagonal. 3 goes into 3 once, 3 goes into 9 3 times. I am not going to try to simplify the p squared and the p and the q and the q squared. I'm just going to wait till the very end. So now what I'm going to do is I'm going to multiply my numerators across. I have 8 times 3, which is 24. And I have p squared times q. That's all I got. Now in the bottom, I'm left with pq squared. So here we go. There's nothing I can do with the 24, so the 24 stays in the numerator. P squared divided by p is p to the first power. I don't need to put the 1 there, but I'm just going to. Now q divided by q squared is q to the negative first because 1 minus 2 is negative 1. Now we know we're not allowed to have a negative exponent for a variable. So to get rid of this negative exponent, we put it under 1 and we're totally finished. We have 24p over q. Sometimes it's really important to put down q cannot equal 0. The reason why you would do that is you want to make sure that people know you can't have q to be 0 because it would make it undefined. All right, next one. Oops. Now on this problem here, you have 2 options. You can get rid of the coefficients first if you can. You can, this one's pretty straightforward. I can visually see that the numerator has a p minus q and the denominator has a p minus q in parentheses. So I know that they both share that. So I'm going to go ahead and cancel these out. They go to 1. Anything divided by itself is 1. So we know that those go to 1. Now, I'm going to draw myself a fraction bar. I'm going to multiply the numerators together. 3 times 1 times q is 3q. I'm going to multiply the denominators together. P times 1 is p. And there's your answer. You want to be more technical, you can say p cannot equal 0. Because remember, can't have 0 in the denominator. All right, next one. This is a little bit more entertaining. You must factor the numerator and the denominator of the first fraction. You must factor the numerator and the denominator of the second fraction. Then you guys can reduce it. You can use the AC method, or you can just use, whenever x squared has a coefficient of 1, you can do a shortcut. Here's the shortcut. All right, my first fraction times my second fraction. All right, my first fraction, I'm going to do the denominator first because it's easier. They both share a 3, so I'm going to take a 3 out. Okay, 3 times x is 3x. 3 times 6, so 3 times 2 will give you 6. I'll double check it. 3 times x is 3x. 3 times 2 is 6, so we're good. Now the numerator, this has an x squared, so I know I'm going to have 2 sets of parentheses. The only way to get x squared is x times x. Now the number 10. So the number 10, I know that 2 times 5 is 10. And I know that 2 plus 5 is 7 because that's your middle term. Okay? This is your middle term. That helps. So I know that I'm going to get a positive 2 here and a positive 5 here. If you wanted to check it and actually multiply it together, you would find you would get x squared plus 7x plus 10. Now, over here in the numerator, they both share a 6. So I'm going to take a 6 out, and I'm going to get x minus 1. You can always double check it. 6 times x is 6x. 6 times negative 1 is negative 6. Now in the denominator, again, it's a trinomial, so when I factor it, it's going to have 2 parentheses. The only way to get x squared is x times x. Now I'm going to take that negative 15 because that's my targeted number. I need 2 numbers when multiplied together give you negative 15, but when added together give you this 2 right here. So I know that 5 times negative 3 is negative 15. I also know that 5 plus negative 3 is 2, and that's your middle term. So that means those are my 2 factors. I have a positive 5 and I have a negative 3. So now what you're going to do is you're going to look diagonally and you're going to look vertically. So get rid of whatever, anything divided by itself is 1. So if you notice there's an x plus 2, there's an x plus 2 here. There's an x plus 5 and there's an x plus 5 here. There's a 3 here and there's a 6 here. Now, only because I can't write with that bright color pencil. These all go into each other once. This goes into each other once. 3 goes into itself once, but 3 goes into 6 twice. So I'm left with, in the numerator, 2 times x minus 1. And then the denominator, I'm left with x minus 3. Do not waste your time and actually distribute the 2 in the numerator, because sometimes you might have to go and factor it again. Don't waste your time actually multiplying it together. Okay, let's keep on going. My daughter's texting me. I'm so sorry. So sorry. All right, now we're going to divide fractions. Now, before we divide fractions, remember back in the day in middle school, you had 2/5 divided by 1/5. The rules for dividing fractions, you leave the first fraction alone. You change the division sign to multiplication. That is a really crazy looking multiplication symbol, sorry. Let's make this a multiplication symbol. And you flip the second fraction. So that's going to be 5/1. Now it's a multiplication problem. You reduce it if you can. And you're left with 2/1, which is 2. So we do the same thing when we have expressions. So let's go ahead and get busy with expressions. First of all, we have 3/4 divided by 5/16. So we leave the first fraction alone. We change the division sign to multiplication. We flip the second fraction. Now what we're going to do is we're going to reduce it before we actually multiply. 4 goes into 4 once, 4 goes into 16 4 times. That's all that happens. So 3 times 4 is 12, 1 times 5 is 5, and you're done. That's your answer. Now the second one's a little bit more entertaining. First of all, I can't do anything with the first fraction, so I'm just going to rewrite it and leave it alone. I'm going to change the division sign to multiplication, and I'm going to flip the second fraction. So whatever's in the bottom is now in the top, and whatever's in the numerator is now in the denominator. Just make sure you multiply them correctly. Now, what I would do personally is I would simplify the coefficients. I know that 3 can go into 3 once. I know 3 can go into 3 once. I know 3 goes into 6 twice, and I know 3 goes into 9 3 times. Now, what I would do is I would multiply across. Oh, time out. I'm going to back up for a second. Whoa. I'm going to rewrite this whole thing. You guys, I totally did something wrong. So, whoa, hang on a second. Again, rewrite the equation exactly the way you have it, or not equation, but the first fraction exactly the way you have it. Can't touch the first fraction. Change the division sign to multiplication. Flip the second fraction, okay? And then whatever's in the numerator comes down here to the denominator. Now, you guys, the 3p plus 4, that is all together. If it makes your life easier, actually put it in parentheses. You guys, it will stop you from doing what I just did. So again, put the whole thing in parentheses if you have to. It'll make your life easier, because I just made the same mistake. I was just looking at the 3p. It's not just 3p, it's 3p plus 4. So here we go. If you notice, these two are exactly the same thing. So this whole thing goes into each other once. Now, 3 goes into 6 2 times, 3 goes into 9 3 times. Now, you guys, I'm going to multiply these together. 3p squared times 1 is 3p squared. I personally do not like to reduce how can I explain it? Just like the variables until the very end. And then on the bottom here, I'm going to get 2p to the third. So I know I can't do anything with the 3 and the 2, but p squared divided by p cubed is p to the negative first power. 2 minus 3 is negative 1. We cannot have a negative exponent, so I'm going to bring it to the bottom, and it becomes positive. And there's your answer, 3 over 2y. I'm sorry, 2p. All right, been a crazy morning. All right, next one. Divide. We're going to divide these once again. I'm not going to touch the first one. The first one is 5a squared b over 2. And I hit that accidentally. Change the division sign to multiplication. Flip the fraction. Now, in this case, I'm going to get rid of stuff. Let me use the gray marker. 2 goes into 2 once. 2 goes into 8 4 times. 5 goes into 5 once. 5 goes into 10 twice. Now, I notice that there's a 2 here. 2 goes into 2 once. 2 goes into 4 twice. Okay? So I'm going to be left with 2 in the numerator, a squared b. The denominator is going to be ab squared. Okay? So what happens is I'm left with 2 in the numerator. A squared divided by a is a. B divided by b squared is b to the negative first power. Remember, we're not allowed to have a negative exponent, so I bring it back downstairs. Okay? All right, next one. This one is a little bit more entertaining, but not that bad. I just rewrite the numerator exactly the way it looks. I rewrite the denominator exactly the way it looks, because there's nothing I can do with it. I change the division sign to multiplication. Now, this right here is actually a difference of squares. That means I can square root the first term, I can square root the last term. They're separated by a minus sign. So we learned this. The square root of 4x squared is 2x. The square root of the square root of 1 is 1. So one of them is going to be a plus sign, one of them is going to be a negative sign, meaning the ones. Okay, that is a difference of squares. If you guys remember this formula from way back, a plus b, a minus b. So that's a difference of squares over here. Okay, now I'm going to bring this one here down to the bottom. That's a negative x squared times x plus 3. So remember, when I flipped these, I went ahead and I factored it at the same time. So now what you're going to do is, if you notice, this 2x plus 1 goes into 2x plus 1 here. This x plus 3 goes into this x plus 3. So now you're left with, in the numerator, 4 times 2x minus 1 all over negative x squared. Now, normally, you guys, we don't like to have a negative in the denominator, so I'm going to rewrite it. I'm just going to move the negative up to the 4. So it's going to be a negative 4, 2x minus 1 over x squared. And that's it. That's all you have to worry about. Okay? Let's go on to the next one. It is good to say that x cannot equal 0. That just is like let you know that you can't have x to be equal to 0. All right, here's the next one. Once again, it's a division problem. We keep, change, flip. But on this case, we have to actually factor it as well. So on this problem here, I'm going to factor out a negative a. So that's going to give me, and I'm going to just kind of rewrite this, is a minus b. I know it looks weird, but I just factored out negative a, and so I know that that's going to give me negative a times a is a negative a squared. Negative a times a negative b is a positive ab. So I just kind of did a little bit of extra work. Now, this is a difference of squares. You can square root a squared, you can square root 1. So, and they're separated by a minus sign, so I know one's going to be a plus 1, and I know one's going to be a minus 1. That part's done. Change this to multiplication. I'm going to flip these. So the bottom one is going to be a minus b. Now this one up here is now going to be in the numerator. Because it's a trinomial, I know I'm going to have 2 parentheses. The only way to get a squared is a times a. Now, this is actually a perfect square trinomial because the only way I can get 1 is 1 times 1, which is 1, and 1 plus 1 is 2. So this is why this is going to be this. Now, simplify it. A minus b goes once, a minus b goes once. A plus 1 goes once, a plus 1 goes once. And that's it. So you end up with negative a plus 1, all over a minus 1. And you're finished. You can't do anything else. In this case, you want to say a cannot equal 1 because 1 minus 1 is 0, and you can't have it to be 0. Otherwise, it'd be 0. All right, and I think that's it. So multiplying and dividing rational expressions, please use those steps, and I will see you in the next section. Let me turn this off.